After watching this video lecture, students will be able to define conversion factors and actually establish metric conversion factors using the Kevin Hates Dates protocol. Students are also going to be able to convert units using dimensional analysis. And dimensional analysis is going to be the primary means of doing calculation problems in chemistry. So what is a conversion factor? Okay, so conversion factors are ratios or relationships used to express measured quantities in different units. And you guys are already actually super familiar with conversion factors just in your day-to-day life. You know that there's 60 seconds in 1 minute, that there's 12 inches in a foot. Some of you may know that 5,280 feet is equal to 1 mile. You know that there's 4 quarters in a dollar. There's plenty of conversion factors that we deal with day to day, and we just kind of understand how to utilize them. Okay, now, unfortunately, with English Standard measurements, you end up having to memorize a lot of stuff. Ask yourself, do you know how many pints are in a gallon, or, how many tablespoons is in a cup? Most of us probably don't have those things memorized, and we probably have to look them up. So conversion factors in English Standard measurements is a little bit of a pain. But the nice thing is that most of them that we'll be asked to use are going to be ones that we just commonly use every day, and those that we don't commonly use every day will be provided to you. Okay, so now that brings me to conversion factors and the metric system. Now remember, the cool thing about the metric system is that all of the various units of measurement are going to be interrelated by powers of 10. And we talked about that last lecture. But if we wanted to know the conversion factor between kilometers, between 1 kilometer and meters, okay, what I would do is I would take my Kevin Hates Dates, because dates cost money, or King Henry died by drinking chocolate milk, and I would use this relationship to move my decimals in the appropriate location. Okay, so first we're starting out with kilometer, we're going to the base unit, which is meter, we're moving 1, 2, 3 spaces to the right. So we know that 1 kilometer is going to equal 1,000 meters. Okay, and now we have a conversion factor to plug into dimensional analysis. And dimensional analysis is basically a setup and a protocol we use in chemistry to keep our units organized, keep us on track to getting the correct setup and the correct answer in multi-step problems. Okay, so we're going to go ahead and take a look at dimensional analysis now. Okay, so dimensional analysis is basically a setup or an organization pattern. Okay, so dimensional analysis, what you're always going to do is you're going to put what you're given in this first box. What you want to convert into is going to go on the top, and what you already are in, or the units that you already have, are going to go in the bottom. Now, what I want you guys to understand is that the lines here actually represent mathematical operations. Okay, so the line here represents division. The lines between various boxes represent multiplication. Okay, so when we're doing dimensional analysis problems, we're always going to set up in this kind of train track type approach. Okay, now when we convert anything in chemistry, right, we convert from one unit to another, remember that our significant figures must be the same after the conversion. So whatever number of sig figs we start with, that's the number we should end up with. Okay, so let's go ahead and let's look at a practice problem. Okay, so what I want you guys to notice here is that it's asking us to convert 200.2 feet into inches. So if we go ahead and now identify, this is what I am given. Okay, and inches is what I'm wanting to get into. So that's what I'm solving for. Okay, now, in order to go from feet to inches, we need to have a conversion factor. Okay, and we already all know this because we know that there are 12 inches equals 1 foot. Okay, so that's something that we're familiar with in terms of our conversion factors. Okay, so now when we plug this in, what we want to do is first, in that first box, we're going to put what we're given, okay, so that 200.2 feet. What we want to be in is going to be inches, and what we are already in, what our units already are provided in the given, are going to go down here, okay, and then notice the 12 inches, that gets plugged in here, the 1 foot, that gets plugged in down here, okay, and then what we're going to do is we're going to do our math here. So 200.2 gets multiplied by 12 because of this line. Okay, and then we divide by the 1 foot. Okay, so if we plug that into a calculator, that's going to give us 2,402.4. Okay, the next thing we're going to do with dimensional analysis is because of the setup, it allows us to do something called a unit evaluation. Okay, so units that match on top and bottom can cancel out. So I have feet here, I have feet down here. What units are left over? That is inches. Okay, and that's what we want to be in. Okay, and then the last thing we need to do, remember that sig figs must be the same after the conversion. Okay, so if we started out here with 4 significant figures, okay, if we come over here, the 4th significant figure is going to be there. So our final answer for this conversion is going to be 2,402 inches. Now, some of you may be asking, hey, why don't we use the significant figures from the conversion factor? Okay, so guys, listen. The conversion factors are not measured values. They are not being dictated by the precision of an instrument. They just are. So we never use conversion factors to determine significant figures. We only use measured values. Okay, so remember, significant figures at the end of the calculation have to be the same as the significant figures at the start when we're dealing with conversions. And we never use conversion factors to determine significant figures. It's always our measured or given value. So let's go ahead and let's look at a little bit more complicated problem. Okay, so in this case, guys, notice we have a combined unit here. We have miles per hour as the unit for our given, and they're wanting us to convert into feet per second. Okay, so what's going to be a little bit different here is the setup. Okay, so when we plug in our given, okay, the 20.5 miles stays on top, okay, and this line here matches up with this line here, okay, so per hour. Okay, so there are 20.5 miles per hour, okay, as our units in our given. And now we need to go from miles per hour to feet per second. Okay, now my suggestion to you is to pick if you want to start with the top or the bottom, and then focus on that conversion, and then continue on and do a secondary conversion. Okay, so what you're going to do now is you're going to, well, I'm going to start with miles. I want to go from miles to feet. Okay, so I know off the top of my head that there are 5,280 feet in 1 mile. Okay, yay, I remembered. All right, so what I'm going to do is I'm going to plug that in. Remember, it's what I want over what I have. Okay, so what I want to be in is feet. Okay, so I'm going to plug in the 5,280 feet from my conversion factor. And what I'm trying to get rid of, or what I already have, is miles. And I'm going to plug this in from my conversion factor. Now, if I stopped right now and did the math, okay, and gave an answer, the units that I would end up with, okay, would be feet per hour, because the miles would cancel. But obviously, feet per hour is not what I want to be in. I want to be in feet per second. So I need to do additional steps to convert this portion into seconds. Okay, so I know that there are 60 minutes in 1 hour, and I know that there are 60 seconds in 1 minute. Okay, I can now use these conversion factors in order to get this hour into minutes. Okay, so now what I do want you to notice, guys, is that the thing that I'm trying to convert is on the bottom, so the want and the have setup is going to be flipped. So what do I mean by that? Okay, well, I have hour here, down here, so I need hours to end up here so that they'll cancel out. All right, so I'm going to use this conversion factor. I have 1 hour per every 60 minutes. Okay, and if I stopped right now and did the math, I would be in feet per minute. But I don't want to be in feet per minute, I want to be in feet per second. So I need to take this another step. Okay, so I have my minutes here. I want to get rid of minutes, and I want to be in seconds. Okay, go ahead and I'm going to use this conversion factor, okay, to get myself out of minutes and into seconds. Okay, so if minutes are down here on the bottom, from this conversion factor, I'm going to take the 1 minute, put it on top. Okay, and then from that same conversion factor, I'm going to put my 60 seconds on the bottom. Okay, and minutes and minutes will end up canceling, and I'll end up with seconds on the bottom of this final answer. So now let's go ahead and let's apply our math. Remember, everything on top is going to be multiplied. So 20.5 times 5,280, obviously times 1 times 1. And then that's going to be divided by 60 times 60. Okay, and so the answer you'll get from that is 30.06. Okay, and if we go ahead and we remember that our significant figures that we start with have to be the significant figures that we end up with, we realize that we have 3 significant figures here. Okay, so we're going to have 3 significant figures in our final answer, which is going to give us this. Then we need to go ahead and do a unit evaluation and check that we've set everything up properly. So we have miles and miles, right? Those cancel. We have hours and hours. Those cancel. We have minutes and minutes. Those cancel. And we're left with feet per second. Okay, and that's exactly what we're looking to convert into. Okay, and this is our final answer. Okay, so notice I've broken up all of the pieces and set them in the correct locations and done my unit evaluation to help make sure that I've done that correctly. Okay, so I want you guys to understand that you should be using whole conversion factors. Please don't combine conversion factors and create your own. I need to be able to see the stepwise work that you're doing in problems like this. So please make sure that you're using the individual commonly known conversion factors. Please don't create your own. So let's go ahead and let's do some quick practice problems. Okay, so they're asking us here to convert 2.2 grams to kilograms. Okay, and I need to be using dimensional analysis. So my given here is this, and I need a conversion factor between grams and kilograms. And that's where the Kevin hates dates, because dates cost money, right? We have kilograms and grams that we're dealing with. So 1 kilogram is going to be equal to 1, 2, 3. So 3 spaces to the right is going to be equal to 1,000 grams. Okay, so that's our conversion factor we're going to be using. We're going to put our 2.2 grams into our given spot. Okay, we want to be in kilograms, so kilograms goes on top. Okay, and we are trying to get out of grams. Okay, and we take that 1,000 grams from our conversion factor. Okay, so we check our setup, right? We have grams on top, grams on the bottom, those will cancel, kilograms will be left over. So we go ahead and we do the math here. So 2.2 times 1 divided by 1,000 is going to be equal to 0.022. Okay, we have 2 significant figures to start, so we're going to have 2 significant figures in our answer like we do here. Unit evaluation, grams and grams cancel, kilograms are left over. Okay, and this is our final answer. And then let's go ahead and do one more challenging conversion factor. Notice they gave us 2.2 miles per hour. Once again, this is a combined unit. You're going to have to make sure that you set this up slightly differently than the problem above. Okay, and so our given here is going to go into that first box. Remember, this line here allows us to differentiate between where this portion and this portion of the given goes. Okay, so we're going to have 2.2 miles per 1 hour. Okay, and that's our given, right? And we're trying to get into meters per second. So once again, we want to utilize conversion factors that are going to get us out of miles into meters and from hours into seconds. So once again, we're going to set this up. Okay, I'm going to first focus on the top because that's the approach that I decided to take, but basically set up one at a time. Okay, so miles and meters. Okay, well, miles and meters, they've provided a conversion factor here that relates meters and feet, okay, but not miles and meters. So I'm going to have to go into, my memory and kind of pull from there. So 5,280 feet is equal to 1 mile. We know this, okay, so we're going to utilize this conversion factor and this conversion factor to get where we need to go. Okay, so first we need to get from miles to feet. Okay, so it's what we want. Okay, so we're getting into feet, 5,280 feet. Okay, and then we have our 1 mile down below. If I stop the calculation here, miles and miles would cancel and we'd have feet, but we don't want to be in feet, we want to be in meters. So now we're going to use this conversion factor to get out of feet. Okay, so we're trying to get rid of feet. We're trying to get into meters. Okay, and at this point, if we were to stop this calculation, miles and miles would cancel, feet and feet would cancel, and we would be in meters per hour. But we don't want to be in meters per hour. We want to be in meters per second. So now we need to start working on the bottom portion of this calculation. Okay, now remember, stuff gets flipped when we're dealing with the value on the bottom. Okay, so we need to go from hours into seconds. We know that there are 60 minutes in 1 hour. Okay, and I'm putting the hour on top because I want to cancel with the hour below up here. Okay, and we know that we don't want to be in minutes, we want to be in seconds. So we know that there are 60 seconds in 1 minute. Okay, and at this point, if we were to perform our calculation, we're going to end up with 0.983488, okay, is the numerical value in our calculator. Then if we go ahead and we look at our given 2.2 miles per hour, the 2.2 is 2 significant digits, so our answer is going to have 2 significant digits. Okay, so 0.98, and then we check our units. Miles and miles cancel, feet and feet cancel, hours and hours cancel, minutes and minutes cancel, and we're left with meters per second. Okay, meters per second is what we are looking for in terms of our units. Okay, and this is how we approach these problems.